Hi viewers, welcome to the next section, Playing Nice, Connecting to Other Systems. In this section we'll discuss working with R from Java and Excel and reading data from databases. We'll also discuss various ways to work on Excel files directly from R. We'll also read data from databases using NoSQL. Now we move on to the first video of this section that deals with using Java objects in R. In this video we're going to take a look at Java string, array and vector operations. Sometimes we develop parts of an application in Java and need to access them from R. The rJava package allows us to access Java objects directly from within R. Ensure that the required files are in your R working directory. First, we create a folder called Java samples in our directory. Then move all the files with the extension .java or .class into this folder. After this, we install rJava using the install.packages rJava command. Here I get the message rJava successfully unpacked. Then I'll load the package using the library rJava command. The library is successfully loaded. Download the three jar files, jri.jar, rengine.jar, and jri-engine.jar from this link, and the reserveengine.jar from this link. Then copy the four downloaded jar files to the lib folder under your R working directory. So, we've placed the files in the lib folder in our directory. You can either use the class files provided or compile the Java code. These class files are created with JDK, and if your JDK version is different, you need to compile all the Java programs. We've already done that. Now we start with how to use Java objects in R. From within R, start the JVM, check the Java version, and set class path. Our version is 1.8.0_102-B14. Then we set the class path. The .jinit initializes the Java virtual machine, JVM, and needs to be executed before invoking any of the rJava functions. If you encounter errors at this point, the issue is usually a lack of sufficient memory. Close unwanted processes or programs including R and retry. For rJava to work, we need to sync up the Java version in the system environment with the rJava version. We use the .jcall command to get the Java version within the R environment. After making sure that the Java versions are identical, the first thing we need to do to access any Java object is set up the class path. We do this using .jadd classpath. We pass the R working directory, since our Java classes reside here. However, if you have the Java class files in a different location, or if you created a .jar file, include that location instead. Once the class path is set, you can verify it by executing .jclasspath. Next, we perform these Java string operations in R. First, we print the string. Next, we get the value of the string. We then use .jcall to convert the letters into lowercase. Next command is to replace the world with SV. We use .jnew to instantiate any Java object. The class name is the full class name separated by /. Hence, we refer to the string class as java/lang/string instead of java.lang.string. The jstrval function emits the equivalent of toString for any Java object. In our example, we get the content of string s. We use .jcall to execute any method on a Java object. In jcall, we're invoking the toLowercase method on the string object s. The capital S in the call specifies the return type of the method invocation. In the second .jcall, we invoke the replaceAll method and get a new replace string back. We list the possible return types in the following table. Now we'll perform Java vector operations. First, we use the sapply command to get all months. Then we check the size and we get 12. We convert it to string, and here the months are in string format. We first create a Java vector object using this line. We use the .jnew function. We then use the add method to add elements to this vector. In Java, to call a method, we use the dot operator, and in R, we use the dollar operator. Thus, we use Java vector $add to invoke the add method on the Java vector object. Next, we'll perform a few Java array operations. First, we create array. Then we print the months array. The two key functions are .jarray to create an array object and .jeval array to return an array object. We create three array objects, months array, years array, and cal array, using the .jarray function. When we print the array object using print months array, we get the object type of each of the array elements. However, when we execute .jeval array months array, we get the contents of the array. The cal array object is a list of two Java array objects, and we also see how to extract array elements in this step. Next, we'll insert a simple Java class HelloWorld. We used .jnew to instantiate a HelloWorld object called HW. We always pass the class name along with the package to the .jnew function. Once the object is created, we can invoke methods. An example of invoking the getString method is shown here. Then we insert a simple Java class greeting with a method that accepts an argument. So here we've saved the object with the greeting Hi World. Then we've printed Hello Shanthi with the print command. And again Hello Shanthi in the form of a string. Here we see the instantiation of another custom object greeting and the invocation of a method. The arguments to the method follow the method name as in .jcall command. Here the string Shanthi is an argument passed to the getString method. Now we'll look at a few key additional useful commands to invoke Java objects from the R environment. First is checking Jvm Properties. You may want to check the Java virtual machine properties if you encounter issues in executing Java commands in the R console. For that, we use these commands shown here. Run the command one after another, and you'll get the Jvm properties. Then we'll display available methods. The jmethods command is useful to get a list of available methods or to get the method signature. The preceding command indicates that the trim method can be invoked on a string object, and it returns a string object. So here are the available methods. We've used jmethods here. We end the video here. We've used Java objects in R successfully.